parts, and I'm a research engineer at Swansea University, and my work is mostly around conductive inks, so solar cells and heaters. So inks, you've probably come across them a lot, from painting pictures of them to printing off your homework with them, but they can be far more than just pretty colours. So what makes an ink? So there are three main ingredients to inks. These are pigments, dyes and particles, the base and the solvent. So let's start with the base. This is what will hold the ink together, and this is usually a plastic, but can also be something organic like cellulose and even flour. So you can make an ink using flour. So the second thing is a solvent. So this can be water or it could be alcohol. This will depend on how hot you want something to be when you're drying it. If you want room temperature, probably go with water. This will hold all of your stuff together. This will disperse your binder or have your binder or resin dissolved in it. And then the main ingredient is your pigments, particles or dyes. So this is usually what's used to give a particular colour to your ink. But today we're going to focus a little bit more on things that are functional. So what do I mean by functional? So we'll give you an example. Start with, you can have things that change colour with light. So with UV radiation, like you get on a bright sunny day if you've had too much exposure to the sun. So what I have right here is a little keyring with two types of inks on them. And the background you see here is a UV changing ink. So right now it's see-through, but if I put some high intensity UV on it, you can see it starts to change to purple. So if I hold that a little bit longer, you can see a nice purple background. And there's another functional ink on here. So as well as light, you can also have things change colour with temperature. So this can be used to tell us how fresh our food is in the fridge and whether something should be cooled down a little more. So what I've got here is a purple ink. That is purple when it's cold, but if I heat it up on my neck for a little while, this will change colour to show that it's gone above 30 degrees. But this can be done for a range of different temperatures and has a lot of uses, particularly in packaging. So you can now see that little leaf in the middle has turned to pink. However, today we'll be focusing on conductive inks. So these can contain a range of materials such as gold, silver, or quite commonly carbon. So this is a low-cost conductive material, can be used in a lot of electronics, including pressure sensors, blood sugar sensors, so those are diabetes, flexible heaters, and even in solar cells. So here today I have a low-cost ink that you can buy online, which is mainly made of carbon. And something to note is that inks, when you're printing with them for electronics, have quite interesting properties. Similar to the ones you get on your wall, but to a greater degree. So if I take this pot and I hold it above my head, shockingly enough, my head is still very much clean. Whereas if I get a paintbrush and I were to give this a little stir, the faster I stir it, the more easily the ink will flow, as it's something known as shear thinning. So as I apply shear, the mixing, it will thin down, making it flow better. This means when I paint it onto my coaster in a bit, it will run readily and easily when I'm painting it, but when I stop painting it, it will hold its shape. The same way when I'm painting the wall behind me, when I stop painting, it won't end up on the floor. But whilst I'm painting it, it's very easy, which is ideal. Another thing to note is that these inks are quite elastic. So when I pull this paintbrush out of its pot, you can see rather than just flow into the pot, some of the ink is actually trying to bounce its way back up to the paintbrush. This is known as viscoelasticity. So visco as in to flow, like our easily flowing liquid water. And elastic as in an elastic spring, like solid, springy elastic spring, which is what you're seeing as I yank it out here, it almost bouncing its way back up. These things can help with the way the ink is put down whilst it's being printed. So let's use it here to draw a few lines, a bit like the ones on the coasters behind me. So these inks are far thicker than the ones you would usually use in school because the size of the particles are far larger usually. So they're nice big conductive chunks of graphite. So another material you will know from school is you'll find it in your pencils. What you probably don't realise or may not realise that it's very conductive. It can be used in circuits, in heaters and in many other things. So if I just finish that off and allow it to dry, you would then get conductive tracks. So if I put this to one side, give it a little while to dry. But why is this conductive when some other inks used may also have conductive materials in, but aren't? And the reason is how much you have. So when you have only a few bits of carbon, in this case, floating around in your ink, you'll only have little areas that are conductive where they're touching each other. So you can't actually get a circuit or a current flow in any direction. Then you reach a point known as percolation, where you finally get that one path going all the way down until you reach a stage where it's conductive and you've got all of these conductive paths where you've got all the joining conductive material going from one side to the other. And that's what we have here in our ink. So to prove the point, I'm going to grab you one that was made earlier that's nice and dry. So this is screen printed, so printed carbon paste, just like the one using down there, with some silver on the sides to help the flow as it's more conductive than carbon. And if I take my multimeter here, I can measure something known as resistance. So resistance is something only conductive materials have, as it is the opposition to the current. So a low resistance means you've got good conductivity. So if I take a measurement here, you can see it is conductive and you have 0.2 kiloohms, 0.2 times 1,000 ohms, and it's similar for each of my other lines. So this can then be used to connect circuits together or even to make it heat up, as resistance does have an advantage. As when you have something that's resistive, in the case of carbon, it will cause it to heat up as you have that current flowing across it. So if we put in a high enough voltage, we'll be able to get something nice and toasty that can heat up my coffee. So what I have here is a coaster connected to a power supply. And if I get my phone and plug it into an infrared camera, I will then be able to show you how hot it is. So if I turn this on and allow it to heat up, we can then take this infrared camera and I can plug it in to the phone. And what this will allow us to do is see how hot and cold different parts of the room are, including our toasty little coaster. So once that warms up and the phone warms up, we should be able to see how hot and cold things are in this room. If I go OK, and I put my hand in front just to show you an example, you can see my cold little fingers waggling in front. And then if we look at our coaster, I bring this a little closer to you, you can see, especially against my cold little fingers, that this is very nice and warm. It can therefore be used to keep drinks nice and hot. And that is one of the many great uses of conductive inks. So, I hope you have enjoyed the session and now realise that inks can be used for so much more than to just make pretty colours. I hope you enjoy the rest of the festival. Thank you for your time. Enjoy!